Right, we're going to take a look at your 2D array homework, the image sharpen kernel. The point of this assignment is to get you familiar with working with 2D arrays, how to iterate through them, and access their data elements. The other point is to become familiar with data types and how working with them, especially unsigned chars, mixing data types while you're working with them affects the outcome. All right, so in this homework assignment, you're actually going to create this 2D array. Let's take a look at what we're going to do. We're told that we need to create this array with 12 rows and 10 columns. Right, we want to use some global constants in order to control the range of random numbers, and we're going to declare all our other variables within main. All right, so let's go ahead and define some of these global constants or pound defines, and then we'll take a look at how we create the 2D array with the dimensions rows and columns and initialize all the array elements to 0. All right. So let's just, should have had this up and ready, create a new project. All right. Let's call this filter. And here's our main that it made for us. All right, since we're going to use the random number generator, standard library belongs in there. We'll print some things out. We'll leave standard IO in here. We said we want to create then, right, the number of rows. And that was 10. Number of columns, 12. Oh, my bad. Rows 12, columns 10. Memory's not good. All right. And then we want these global constants, and we want unsigned char. All right, so high is 255. Right, low. It's not always the best idea to copy out of a non-text document. It can embed some characters and cause problems, but let's see if this works for us. All right, so constant unsigned char, high and low. All right, now we want to create an array of that many rows and columns inside main. Let's get rid of. All right, so unsigned char. Right, and I have my original array. So that's where our original data is going to go. It's rows, columns. All right, so 2D array, row major order. First number we give it is always the number of rows. Second number is the number of columns. To initialize a 2D array to all zeros, if I just give it this list, that's the list for a 1D array. So for a 2D array, we have to have 2 sets of curly brackets to avoid a warning about our initializer list. Right, that will initialize then all the elements in our array to 0. Right. The next thing we want to do is we want to go ahead and fill one array. So this one I called original. We'll fill that array with random numbers in the range high to low. We're only going to fill the array interior. The outside edge value should all remain 0. It says see the example. Let's go up and look at the original. Notice everything in the first row, row 0 is zeros. Everything in the last row is zeros. Column 0, 0, column, the last column is all zeros. So the interior is what we want to fill. In other words, we want to start with row equals 1, column equals 1. We want to keep going. We want to fill everything here. The last column will be the number of columns minus 1. The last row will be the number of rows minus 1. Right. I'm going to go ahead and create a variable, an integer variable here. And if I call this row limit and say that my row limit is equal to rows minus 1, column limit is equal to cols minus 1. I equals, I'm going to use R for row equal. So I'm going to start row equal to 1. R less than, well, actually I can just say less than rows in this case. R plus plus. that will work with one row at a time. Now to iterate through the columns, C less than columns, C++ or, right. And now to fill that, right, so my name of my array is original. I'm at row R, I'm at column C. I'm going to call the random number function. I'm going to mod that by my high minus low, add 1 to that, and then add my low range back to this result. Now here's the thing. This is going to return an int, and this is an unsigned char. We just see if we compile. Actually, it's telling you about my unused variables. All right. There are warning levels I could have turned on that would actually indicate the fact that this is returning an integer, and I'm about to assign that to an unsigned char. If I want to, I do a static typecast here saying unsigned char, right? Because rand returns a data type called int. Let's actually see. All right, I'm going to try to get to c++.com. I'm going to look at the rand function and rand. So rand's the name of the function. It doesn't expect anything. The parameter list should be empty, but it's going to return something of type int. And if I want to store it in an unsigned char, right? Yes, C will automatically truncate it for me if I don't do the static typecast. But by doing the static typecast here, right, I'm telling the compiler specifically how to treat this. All right. So I'm going to put a note. Rand function returns int type. Cast it to unsigned char. Right, unsigned char before assigning it to the array. Right, the array type is unsigned char, so I'm assigning like type to like type. All right. Now, one of the things you need to do is you need to display this. So let's go ahead and display the original array. Same thing, we're going to iterate through this array. Actually, let's just go ahead and take a look at our logic here. Do run the cursor. All right. Oh, because that's unsigned char. Oh, that's annoying. Because this is unsigned char, it's actually showing, it's trying to represent everything as a character here for me. Oh, that's not fun with a debugger. Let's display it. There's some other things we might try to avoid that with a debugger. But let's just go ahead and say int r equals 0, r less than rows. Right. All right. Now let's just give everything some space, right? If I just say %, actually %u, unsigned char. And if I now say original, right, at index r, index C. All right, if I don't leave any spaces there, it'll run all the numbers together. All right, I have 10 columns. Okay, so my range of numbers is 0 to 255. At most, I'll use 3 spaces to print out a number. Maybe I'll just make this a field width here of 5. And if I print that out, we're going to see that I'm still not going to get everything on its own line. Right? Actually, what I got is it kind of looks like it wrapped around and made new lines for me. The problem is I've got way more than my 10 columns out here. Right. So print the data in each row. That's what this loop is going to do do for us, sorry. Now let's go ahead and print so we want to start printing the next row on a new line. And all right, so if we build and run, the top row is all zeros, the left column is all zeros. But notice my bottom row is not 0 and my rightmost column is not 0. That's because these limits here weren't quite right. Right? By using rows here, if I said R less than rows, well, rows is 12. So since I started this at 1, right, this went through 1 through 11. This was true for 1 through 11. 11 is my last row index, right? What I really wanted here is rows minus 1, right? This row is, right, rows minus 1. This row is rows minus 2 in terms of indices. That's why we're going to use rows minus 1 quite often. I just defined a variable called row limit, and that's why I defined a variable called column limit here. Now if I build and run, now we've got, right, upper row 0, last row 0, left column 0, right column 0. So we've gone ahead then and filled this in. Right. The other thing the homework assignment told you was if you want to get the same set of numbers I've got here, it tells you how to seed the random number generator. So seed the random number generator with a value of 1 to produce the same results. So here, seed random number generator with a 1 to produce same results as homework example. So seeding the random number generator, that's the sran function. We pass it to number 1. And if we run this now, and we want to try to compare, all right, 41, 35, 190, 132, going down this column, 82. It looks like our original is the same. All right, so that helps you with how to print out the array, right? You still need to display a title before you get there. That helps you then with filling it with random numbers. What it doesn't help you with is sharpening the image filter, right? That is your exercise. You're given this 3x3 kernel to sharpen it with, right? You're also given an example, right? A set of numbers, what these will work out to. You're given this information here as to how to access your neighbors. So the center of the kernel is always going to be at coordinates RC. right? What you're going to want to do is you want to start the kernel in the first row, first column. So first row, first column. You want to start here and think of this as being your RC. And then your neighbors here around this are these immediate neighbors. I'll help you with the filtering process. For int r equals 1, r less than row limit, right? You want to stop at that next to last row. The last one in this row you'll apply this kernel to is here. So you'll want that to be your center one. And then, actually, so let's think about these indices. All right, rows is 12, row limit is 11. All right, so this is index 0, index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So remember the index of the last row. So you've got 12 rows. The index of the last row in your array is 11. You want, I was referring to, I was saying rows and pointing at the columns. You want this to be your last row. So index 10 is your last row. If this has a value of 11, then you say r less than row limit. Right? Anyway, we're going to start at the first column. C is going to be less than our column limit. So C, right, column 0, last column is index 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so the last column you want to work with happens to be index 8, right? That should work here because columns is 10, column limit is 9, 1 less than 9 is 8. Right, there's other ways you could write this. This is just the way I happen to be writing it. Other ways to do it that are correct. Right. So apply sharpen kernel to array location R. C. That's your center. But you need another array to store the results in. Right? It needs to be the same size as the original. I'm just going to copy this. It's going to be called filter. I called it filtered, I think. All right. I initialize it to 0, so my outer edges will have zeros. Again, the final result. So what I want to store this to is my filtered at RC. Right? I don't want to change what's in the original array. And then I want to apply the formula. So I want to take original at location RC. And then what does my sharpening kernel say I should do with that? My sharpening kernel says this is my RC right here, the number 5. I need to multiply that by the number 5. Then I also need to access the other neighbors. Right. If I take -1 and multiply that by one of the other neighbors. Let's go ahead and let's work with the neighbor immediately above. The neighbor immediately above this is what position? Think of it's in the same column, but it's 1 row less than where we're at. So if I go to the original at 1 row above in the same column, I get that. Right? It's that index position. All right, now think about the fact these are unsigned numbers and you're multiplying this by a -1. Is it good to mix those data types? Right, what happens when you multiply an unsigned number by a -1? Right, so I'm going to stop this here in terms of this program, right? I've helped you through a good portion of this homework. You'll obviously need to finish this formula. I'll save this and let's create another program. So I'm going to create a new file. I'm going to call it maybe mixed for mixed data types. I'm giving it a short name, putting it in the debug mode. All right, now I'm going to remove this file from my project main. Here's my new one. Then maybe I'll print some things out. Maybe I won't. All right. All right. So I have this unsigned char. I'll call x. If I set it equal to 0, what happens if I say x is equal to minus x? Or x is equal to x times minus 1, which is what we were doing in our other example. So if we were to print out, so use %u, here we'll say x is, right, we should see 0 in here. Now let's go ahead and say x times minus 1 is, well, we stored that back in x. Let's run this and take a look at it. X times minus 1 is 0. Okay, 0 times anything is 0. That looks reasonable. What if x is 1 here? So if I change x from 1 to that, so now instead of 0, right, we know 0 times anything is 0. And that was the result we got out of our C program. But here I get x is 1. X times minus 1 is 255. Why did I get that? All right. Well, we can only store unsigned numbers. I'm trying to... This website talks about character or char type overflow, right? Tells you can think of a char, an unsigned char, well, in this case, a signed char, here, as being sort of a circular wheel, right? So signed numbers, we can represent an 8-bit number. We can go from minus 1 to 128, 0 to a positive 127. When we mix the data types in here, right, as we did, when we mix the data types, we're basically forcing this back into an unsigned number here. And I use %u. So what's happening is, actually, let's do run to cursor here. All right. So x now, right, is the number 1. Next line, x is 255. Well, in binary, all right, let's stop this. Right. Unsigned char is 8 bits, right? So 1, so decimal 1 is, I'm going to separate these in groups of 4 to make them easier to read. All right. So there's my decimal value 1. Negative 1, right? Negative 1 in 2's complement, right? So decimal minus 1 is 111, 111. in unsigned, binary, what is 111, 111? Right? The answer to that is decimal 255. Right. What did we get out when we ran this? We did 1 times minus 1 is 255. We get out 255. Or if I just even said, let's assign minus 1 to x. So when we assign that minus 1, we get out 255. All right. Now, if I make that a %d, that says print that in base 10. The u set unsigned. Do we get a different result? No, right? We got the same result because we stored this in an unsigned char. Right. If I say here to treat this as a, so if I typecast this to a signed char, then we get out minus 1. What we have to be aware of is the way that our programs store information. Right? In the computer, things are stored in binary. So making this assignment right here of -1 is literally saying, well, let's assign this binary 111 to x. When we printed out x before as an unsigned char, it gave us 255. But now when we tell the program to interpret this as a signed char, we get out -1. You have to be careful when working with data types, right? This data type, technically this constant here, is a signed integer type. But because I assigned it to an unsigned char, we ended up with this binary pattern in memory, right? When we typecast it. So here, when I did this, this is called a typecast. It says for purposes of this, treat what's stored in memory as a signed char. Right? Unsigned char, well, that was its data type anyway. But if I specifically say treat that as an unsigned char, so that's a typecast, right? When I put the data type in front of the variable, it says just for this operation, cast this to this data type, right? We get our 255. Well, that's why I said when you work with this, you've been asking me all semester about why it's bad to mix types. Wish it would just default to my current folder. Here was our program in main. Right. So think about what's going to happen when you multiply this -1 times the unsigned type. Right. The homework told you to use unsigned chars. If this is not an unsigned char, if it's a signed number, you'll get different results than if you treat it as an unsigned number. So I would recommend running the homework assignment with the unsigned chars, and then I'd recommend turning around and changing these. Well, if we work with signed chars, we have a hard time then working with we can't have the range of 0 to 255. And if we're trying to really represent what might come through in an image, what comes through in an image is unsigned char data. So what would happen if we were to typecast this to signed and unsigned? So let's go back to this example. All right. So let's say now I have X. x is equal to 250. X is equal to 1. Y is equal to 1. So what's my result? If I then have z, and if I say z is equal to x times 5, like our filter, plus minus 1 times y. All right, y, z is 0 until z has whatever garbage. So until I hit next line there, z came up with 4. Well, that makes sense. 1 times 5 plus negative 1 in this case, we came up with a value of 4. All right. What if y is now 6? X is 1, y is 6. So 1 times 5 should be 5, plus minus 6 should be minus 1, but what are we going to get in z? 255. Right, simply because we're mixing data types here. What happens now if I were to say, treat y as an integer, treat x as an integer? So I'm typecasting, right? When I put the data type right before the variable, it says typecast x to an int for purposes of this computation, right? Typecast y as an int. Right, now, what value do we get in z? We still get the 255. Why do we get the 255? Simply because we end up with a minus 1 out of this expression, which is still an integer, but it's assigned back to an unsigned number. So what if we had a signed char? Actually, what if we had an int? So zi is our int. We say zi equals, just copying that. All right, the same calculation. Let's run the cursor. So in this case, z gave us 255. That's what we expected, but now we got 8 out of this. How did we, oh, sorry, we haven't gotten it. That's the garbage. I have to execute that line. We get minus 1, which is what we'd expect. 1 times 5 is 5, plus minus 1 times 6 is negative 6, minus 1. So you can see the difference then in your data types makes a difference in what you get for your output, right? Meaning what I generated back here in the homework, this I stuck with the unsigned chars, right? But if I do the math with the unsigned chars, if I mix these data types and multiply this by negative 1, right, if you do that, you will get these results. If you typecast these to integers and then assign them back to a signed data type, you get a different number. But I said in this particular case, I wanted you to work with unsigned chars. I want you to see what happens when you're mixing negative numbers, when you're restricted to a range of 8 bits, what the results are that you get from this, and the importance of matching up data types, right? Mismatched data types are likely producing results that you don't expect, right? All because of the way they're represented in memory.